So they say that the best way to deal with international travel is when you land, you should just stay up the entire day so you really tire yourself out, and then that night your body will take any time zone you've set for it. So what they didn't say was you should land early in the morning and then go to a conference and give 2 talks in the afternoon. I'm pretty sure this is going to do wonders for the jet lag. I don't know what the effect on the talks is going to be. So before we get started here, I should point out that someone at a droidCon UK in the past did point out after one of these talks that I had in fact completely wasted their time, which is quite true, and that they were very unhappy about it. But I did want to point out that this is intended to be a waste of time. If anybody is in here thinking that it's not and that they don't want to waste their time, I invite you to leave now instead of coming up to me afterwards and saying, I'm really unhappy that I stuck around for that.
Also, if you find the talk funny, you can come talk to us afterwards. If you do not find it funny, that's okay, you can go do something else.
And are we good? Is this a good time to start? Are we still warming up the crowd?
They're ignoring you.
Now I see 2 fingers in the air. All right. All right, great.
One for each of us.
And so we begin. Hello, and welcome to the talk that we have entitled ISO 9004.1, Specification of Quality Management Process in the Specific Realm of Computer Software. This is the official and real title for the talk, and we like to simplify things with acronyms. And we realized that we could hardly spell, much less pronounce this acronym, so we changed the name of the talk.
So this is a much proper name, quality. And the best thing we could figure out for this acronym was quick uptake and like is totally. See, that's quality right here.
Or, as Steve Ballmer would say, quality, 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 quality.
Or Q14.
Someone pointed out, though, that there's, in fact, 15 on this slide, so there's a little quality problem. I am Chet Haase.
It's just enough by 1 error. No, they didn't find that funny.
No. It was pausing for dramatic effect. I am Chet Haase.
And I'm Romain.
And we are going to teach you about how to achieve software quality in your organization, just like we've achieved it in ours. This is the rough agenda that we will be covering today. We would like to tell you a little bit about us, and then we will be defining some terms for you. It's important to know what we're talking about. And what do we mean by quality? And by we, I mean I.
Then we're going to have an important equation. We realized that having equations on screen make you look smarter, and so the more Greek letters we have, the smarter we will appear. So there will be a lot of that.
Metrics are obviously very important in quality. We need to measure as much as possible and then display charts and graphs to show that we've measured these things. I believe everybody in here, except the people on stage, have misconceptions about what quality actually is. So we're gonna cover some of those.
Then we're gonna tell you, of course, what you can do to implement quality in your company.
And hopefully we'll have some time for questions. And then we'll see if we have some time for answers. First, a little bit about me. I run a company called Quality Consultants Incorporated. I am the president, founder, owner, CEO, COO, CTO, and chairman. I am a consultant in the company. I have done engineering for many, many years, and all of those years I was creating bugs. However, from 2015 to the present day, I have been presenting in places like this on the topic of quality. And during that same time, not coincidentally, I have created 0 bugs. Also, I'd like to point out that I have a certificate of quality, which was awarded in 2019. We'll get back to that later. And just want to emphasize again, 0.
So I work at the same company. I hold the title of Chief Quality Officer, or CO. I'm also the quantitative quality quack, or cuckoo quack, and I am the sole employee. Unlike Chet, I have no experience whatsoever in engineering, which means that, like Chet, I have created 0 bugs, which makes me uniquely qualified to work on quality. And this is how I earned my certificate of quality the same year as Chet. Again, I would like to emphasize this number.
0. All right, so we talked about certificates of quality. Here's one. There's a couple of things I'd like to point out on here. First of all, it does say quality not once, but twice. Second of all, it's mine. It was awarded to me. And third of all, I'd like you to take a look at the quality of this certificate. If we zoom in there, this is high quality indeed.
And I have my own certificate that you can see here. And the quality is exactly the same as on Chet's. But let's define quality. What is it?
So I like to look at the Latin roots of all words. That's where everything goes back to. What better way to define a language than on another dead one? So if we take a look at the roots for quality, we'll look at qual, which means what, which obviously stands for IT, and why, which is why? So what? IT? Why? And I have to say, exactly, right? So this was enough of a definition for me, but I wanted to take it a little bit further.
I disagreed, and I studied French for many years, so I decided to
Your French is very good.
Thank you. It's pronounced qualité. And if we look at the French root of the word, we have "ca," which means only, "lit," which stands for bed, and "y," which means for there. Only bed there. Which is good because, in the words of a famous French writer, Voltaire, when the product is so bad, one can only sleep. We also found another quote. Does any of you know what it means? Because we don't.
We also don't actually know how to pronounce that, so we're just going to let that sit there. This is a quote by, it doesn't actually matter. All right, so what do we mean by quality? There's a few different ways of looking at quality. Do we mean tests? There's a load test. There's many, many other kinds of tests. So what do we think? Who thinks that quality means tests? This is the audience interaction part of the show. Okay, we have 3, 4, 7 hands raised.
Yes.
The rest of you lose.
You are right.
Obviously it means tests. It's not quality if you can't test and verify that you, in fact, have quality.
How about quality metrics? Are they useful to define quality? Here's an example. So the green bar is the number of defects, and the blue bar is the quality. The fewer defects you have, the higher the quality. So who thinks that metrics are important?
Little
Yes.
more participation this time. Well done, well done. Okay, and then finally, what about eliminating bugs? What about the process of actually getting rid of defects in your product? Is that quality? A little bit more, and you all lose. So here's a quote that I particularly like. Quality software has no bugs to eliminate. So you started from a bad premise. That was my quote.
But we can define quality with an equation. It's called the equivalence theorem of code, or ETSI. And it goes like this. The number of bugs is equal to the number of lines of code
Times the number of files.
times the number of statements.
Times the number of conditions.
And then we square that because we see a lot of math doing that.
Equations like this are typically summed over a range.
And this sum is from x equals 0 to infinity. We're not sure why x, but every time we see a sum, typically there's an x. So, and finally, because we do software engineering, it is not rocket science, it's not really engineering, so we have an error term.
That pretty much handles everything else.
It's between minus infinity and plus infinity.
And with this equation, you can come up with the exact number of bugs in your code, right? So it's good to have equations like this, very useful. All right, let's talk about metrics. Let's look at some data. So this is working with our customers. We've done some use cases. We've compiled some data. So where do you think bugs live? Do they live in the documentation?
No. Do they live in the specification?
Not really, no. How about memos? Notes people send around the office?
I've never seen a bug there. How about emails?
No, not really. Desk drawers? Do people hide bugs in their desk drawers?
Not the kind of bugs we're talking about?
No, no.
Monitors?
Not really, no. That's just for displaying stuff. How about conversations that people have in the coffee room?
Depends what they ate, but not really.
Meetings? We talk about bugs, but that's not really where all bugs live in the code, right? Very important. Think about that, code, okay? We'll come back to code later. All right, who writes the bugs that exist in the code? Is it the people in the sales department?
Not really. It's not the marketing people.
And the administrative staff? I don't think so.
Not the barista.
No, something went horribly wrong.
Management, yeah, we had that client once.
Yeah.
So we had that client, they had managers who used to write code and thought they could still write code, and that happened. But really, in general, all the bugs are with engineering.
So it's all in the code, and it all comes from engineers. Just keep that in the back of your mind. All right, so how does code relate to number of bugs? So here's some more metrics that we came up with. Here's the amount of code in a particular project that we studied. So over time, you can think of time as being on the bottom axis, or what we call the x-axis. X, just like you saw in the summation on that earlier slide, right? X will always get you.
We also measure the number of bugs, and you can see a similar trend. Now you might wonder about those little spikes, what happened there?
So that was interesting. It turned out there was an engineer on the project who mistakenly just one day deleted a crap ton of code. Just got rid of it and spiked the number of bugs. So even though there was less code, there was more bugs just because it wasn't really the right way to go about reducing the amount of code on the project.
Thankfully, we fixed the issue, we fired the engineer, we brought the code back, and you can see the number of bugs rise again, but with the right slope.
All right, so what is it we want in software? We want the number of bugs on our projects to go down, hopefully all the way to 0, which means, given the equivalencies that we just looked at, that we want the amount of code to go down. Right?
So how can we achieve that? So that's where we're going to talk about those misconceptions, or how we like to call them the believable solutions, or BS. The first one that a lot of you are familiar with is called the Guidelines and Ground Rules of Methodology Excellence, or GAGME. There are several steps. First, we need to identify the processes. Then we document the approach to those processes. We form teams to discuss the methodology for the processes. We present the findings to the team. Then we have to train the team. And finally, the engineers write code. So if we examine that from a bug perspective, here's what happens. In all those first steps, no bugs are created, none. But in the final step, lots of bugs, all the bugs even.
All right, well, what about better specifications? This is also called BS. We comprehensively itemize the requirements, we identify the problems, we propose solutions, and then the engineers write the code. And once more, you see all the things that didn't involve writing code produced 0 bugs. All the bugs were created from the code writing.
There's also the code review approval process, or CRAP. And here's how you think it works. Engineer A writes code. Here's my code. Engineer B reviews the code and gives it back. Thank you. Engineer A fixes the bugs and finally submits the bug-free code. So the problem here is that when the engineer A writes code, there are bugs, obviously. no bugs during the review, there's no more bugs after they're fixed, and finally when we submit there are no bugs. However, this is not what happens in reality. Here's what really happens.
All right, so the engineer writes the code, great, creates bugs, we know how that works. Engineer B reviews and suggests, which created no bugs because there was no code written, it was just suggestions. Engineer A writes more code, which means more bugs, right? We know how this works. We saw the charts and data earlier, didn't we? And then the engineer A submits buggy code, right? So almost everything there is just creating more code bugs.
So we have another solution called the Product Management Supervision, or PMS. It involves PMs. So the PM identifies the feature, it tells the engineers to implement the feature, it tracks the feature implementation. So usually it takes the form of the PM just sitting next to you and going, are we there yet? Are we there yet? Are we there yet? Until we are there. And finally the engineers write the code. And once again we see the same pattern. The PMs don't create bugs, they create the features. But when the engineers are involved, bugs happen.
All right, here's another one. Work hours is never ending, right? Whiner. So the engineer writes some code, creates some bugs. Engineers stay late to fix those bugs, creating more bugs. Engineer gets tired, writes even more code, creates even more bugs. And then the engineer sleeps, creating 0 bugs.
So now it should be pretty obvious that whenever there is code, there are bugs. So what can you do about it?
So here's what we'd like to see. We saw this graph earlier. Number of bugs goes down, the amount of code goes down. So how do we achieve that?
So the first solution is to make up the data. This is what we did. This is usually what we do for our own company.
In fact, we're so good at making it up that the second solution is you can pay us to make it up for you.
Or you can fix your organization. And we're going to look at this third solution, fixing the problem, or FTP. We didn't really like the acronym, so Chet came up with this really better one called HERO. And we start by reorganizing the org, so it's a reorg. So here we have a typical organization. We have the managers and we have the engineers, and they have their computers connected to a router that's connected to the internet.
They write a bunch of code, they submit the code, sends it out to the internet, and now all of those bugs are out there for everyone to have, right?
So the first obvious step is to remove access to the internet.
If they can't get the code out there, then nobody has to have access to these bugs, right?
Unfortunately, nowadays, engineers are smart, they have smartphones, they will find a way to reach the internet. So we're going to remove access to the router and the network so they cannot talk to each other. They can't work with each other.
It turns out engineers don't actually like people anyway, and they're perfectly happy working on their own. So they just sit there in their own workstation and create their own bugs, and then they find access to the internet, still get them out there.
So obviously we have to remove access to the workstations.
Unfortunately, everybody has multiple machines, and so they just went and created them elsewhere, so we finally took the ultimate step of just removing the engineering department. And this works. You don't have engineers, you don't have code, you don't have bugs. It's pretty simple if you think about it.
So what should you do if you don't have engineers anymore? Hire more managers, or Here's what managers do and what managers don't. Managers manage people. They do not write code.
Managers attend meetings. Managers don't write code.
Managers talk with other managers. They do not write code.
And managers facilitate cross-functional growth strategies and interdepartmental team facilitation for the purposes of collaborative interfacing and department-wide coordination. They do not create bugs.
Emphasis. What about sales, or what? So sales are important because they will create your first release, the release 1.0. They will sell it to customers, they will bring money, and you'll be able to hire more engineers or really more managers. Then we'll have a release 1.1, but then problems starts appearing. To create that release, you have to write more code, you create more bugs. And the problem keeps getting worse and worse because you have your second release, 2.0, more bugs, 2.1, more bugs, 2.2, more bugs, 2.3, more bugs. And finally, you achieve corporate realization or company knowledge, called CROC. And the trick here is to take your release 2.3 and re-release it as 3.0. And if you go to an app store these days, you can see that every release note says bug fixes and improvements. This is what's going on. And you keep going, you re-release 2.3 forever and ever, just increasing the version number.
Perfect solution. Don't need engineers if you're not writing the code, right? And if you don't have engineers, you don't have the bugs. And I think most of you in the audience, being engineers, are thinking, whoa, 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 what about me? What about engineering? Or we? All right, so here's how it goes. There's no more coding happening, which means that you are not creating more bugs, which means that there is more quality that you are creating by not doing any of those other things, which means that now you all have developed an expertise in quality, and in fact, you are now experts in quality, and now you too can give presentations on quality. I hope you all have learned deep things from this presentation. We are at the end of our talk, and I believe we do have time for some quality questions or Everybody feel good about that? Know what you're doing? Know how to act on that? Or are there hard questions?
If you have a question, raise your hand so we can bring a mic to you.
They're looking for higher quality audio. Yes. It could imply that there's some quality issues with the presentation itself. We'll look into those numbers. Math, I don't know if you picked it up from that equation, not really our strong suit. But thanks for that bug report. Yes, hi. You're looking around like, did someone else raise their hands? I don't know why he's looking at me.
How do you assess quality of a quality assessment?
This is a recursive problem. We haven't solved it yet. We need to hire more managers to figure it out.
If I can remember back to when I did programming, recursive problems generally involve infinite loops. So I think that's somewhere in there. Yep. Yep. Thanks. Yes, hi.
He was first.
What if salesperson learn to write code?
I missed that. Did you get that?
I did not get that.
What if sales or other part of your company learn how to write code instead of engineers?
Oh, then you should fire those people as well. Absolutely. It doesn't.
So,
I mean, to be clear, it doesn't have to be an engineer. It has to be anybody that is acting as an engineer. Even if they're pretending, even if they're doing a really horrible job, if they're being an engineer, if they're writing code, they're writing bugs, they need to be out.
But we've seen that happen before, where we fired the engineers and then they shave their beard, they put on real clothes, and they pretend they're from marketing to get rehired, and they start writing code. And that's usually how we detect them, and then we fire them again.
So about those marketing, can I fire them now, just to be prepared?
Oh, proactive strike on marketing. Yeah.
Now, you can't, because when you want to ship the same release over and over again, you will need marketing to sell that.
Yeah, but if we're hiring the marketing people that are going to our HR department is looking for people. If you'd like to talk to us afterwards, it'd be great. And there was one over here.
One of the slides states that we all now experts in quality. So are we now reliable for certificates as well?
Are you reliable for? Are you liable for liable? I like liable for certificates. Yes, you will be blamed for all certificates. You are responsible for all elements of quality in your organization. Certificates is certainly an important part of that.
And to be clear, if you follow our advice, we are not liable. You are.
So now you fired all the engineers, right? And then there is no more code.
Yes.
So there is no more quality checks that you have to do. So I'm wondering, what's your next career move?
So if we only had to worry about our own code, you'd have a very good point. However, the other part of the trick here is we're consultants. There are many, many engineering companies in the world.
Not only that, but there's a recursive solution. Once all the engineers have been fired, we can go back to those companies and tell them that they're wrong and they need engineers to create new products. And then we can keep going and refire the engineers, rehire them. Money, that's what we're after.
It's a beautiful cycle of perpetual
Business.
employment. Yeah. Yes. Right there.
So if we're hiring more managers, do you believe in a flat structure? Should we have a broad-bottomed company, for example?
So if we hire only managers, we cannot have a flat structure because they will have no one to manage. So we need managers reporting to managers. We haven't solved the problem of the leaf nodes in that hierarchy, but we're working on it.
It's just, it's what we call in our business a pyramid scheme. You just keep hiring and people just keep moving up the pyramid as you keep funneling people on the bottom that then hire people under them. It's, yeah, it's beautiful until they go out of business. But we've moved on by then, so it doesn't matter. Yep, thanks. All right, shall we take a couple more here? I like how I asked that as a rhetorical question, like I'm waiting for someone to answer me. No!
Well, he's trying to ask the question.
Yes. No, I had a question of my own. Go. When did we realize we had such a mastery of quality?
He has the question to you.
Just me?
Yes. Well, a lot of people who worked with Chet kept telling me that he should move on from engineering and maybe focus on something else. And I'm going to prove my point. What is your job nowadays?
So, you could look at it as I developed an expertise in quality. Perhaps a more cynical way of looking at it was I didn't really have anything else to do. Yeah.
You just wanted to learn all the ways an engineer could fail.
I'm not there yet. All right, one more question. Is there somebody behind the stage asking it?
Over there.
Yes.
So in a previous slide you showed that engineers make most of the bugs, but also managers. Do you reckon that ratio from managers to engineers compensate for about equal bugs each?
Well, the ratio, correct me if I'm wrong, the ratio of managers to engineers should be NaN. Right? I think in a perfect organization, it's going to be a divide by zero error. Check my math, because it's really bad. All right. Thank you.
Thanks.